In this video, we are going to find integers x and y such that 5x squared minus 6xy plus 7y squared equals 383. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. Our first step will be to complete the square on the left-hand side of the equation. So first I'm going to multiply both sides by 5 so that the coefficient of x squared over here will also be a perfect square. Where 25x squared minus 30xy plus 35y squared equals 1915. Then I'd expect to have perfect squared starting with 5x, and the other term will be minus 3y, so that the xy term will also have minus 30 as the coefficient. Now within the square, there's the term 9y squared. So outside of this perfect squared, I will have 26y squared, and adding the yellow square with 26y squared, I have 1915. And from this, we can do some bounding, because 5x minus 3y all squared is non-negative, so that means 26y squared is at most 1915. And so dividing both sides by 26, we have this fraction, which is approximately 73.6 and so on. But that's not important, because we know that y has to be a squared, and this square is less than 73, so that means we have this range for y. Now in fact, I can already try one by one. We have only 70 possibilities for y, but this is not what I want to do. Instead, I'm going to do some mod on both sides of the equation. If I do mod 3 on this equation, mod 3, then the 6xy term will vanish, because 6 is a multiple of 3, while for 5 is congruent to minus 1 mod 3, 7 is congruent to 1 mod 3. That means we have minus x squared plus y squared is congruent to 2 mod 3. We'll quickly find the remainder when 383 is divided by 3 by just adding the digits. Now notice that any integer squared is either a multiple of 3 or congruent to 1 mod 3. And so if we put various possibilities inside this congruence equation, minus x squared plus y squared has to be congruent to 2 mod 3, then the only option would be x squared congruent to 1 mod 3, and then y squared has to be congruent to 0 mod 3, so that minus 1 plus 0 is congruent to 2 mod 3. Now from this, we know that apart from having the range y is between minus 8 and 8, we know that y squared is also congruent to 0 mod 3, which means y is a multiple of 3. That leaves very few choices for y. Y can only be either plus or minus 6, plus or minus 3, or 0. Now we can try one by one. Clearly it's not 0, because we'll have 5x squared equal to 383, clearly no solution. Where y is equal to minus 6, then we can use the equation after completing a square. We have 5x plus 18 all squared plus 26 times 36, and that equals to 1915. Then with 936 for the product. And so 5x plus 18 all squared is equal to 979, but that's not perfect square, so no solution. We can do similar things for y equals 6. Similarly, it's just 5x minus 18 instead of plus, but it also has to be equal to 979, so again no solution. And what remains will be when y equals 3 and minus 3. When y equals minus 3, we have 5x plus 9 all squared plus 26 times 9 equals 1915. And so we have this perfect squared has to be equal to 1681, and that's 41 squared, so we can proceed. Five x plus 9 is either 41 or minus 41. For 41, we cannot find integer solution for x, but for minus 41, we can. So x either equal to 32 over 5, which we reject, or minus 10. So we have one solution pair now. And finally, when y equals 3, using a similar argument, I can say 5x minus 9 equal to either 41 or minus 41, and we'll solve x equals 10 or minus 32 over 5, which we reject as well. So therefore, xy is either 10, 3 or minus 10, minus 3. And this is the final answer. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.